Just so you know, I also go by my nickname, Dia, which makes life simpler. You don't have to pronounce that. Can you hear me all right at the back? Okay, great. So I'm a postdoc at Isabelle Dautriche's lab at Aix-Marseille University in Marseille, France. And today I'm going to present a study that we recently completed in our lab. So any feedback from you would be very, very helpful at this stage. So here we looked at whether 18-month-old infants look more at gesture forms compared to other manual actions. And this question is linked to the big picture question that, the capacity to detect linguistic signals in the early stages of life is very important for language development. And we have a lot of evidence from how speech sound discrimination from other sounds is foundational for speech perception and later language development. And this appears very early on in life. Even newborns show biased attention to speech sounds over artificially produced sounds. And over a few months later on, they even prefer speech sounds from other natural sounds. It's, however, not just the auditory modality of language that infants are taking into account. They're also considering the visual modality of language. So 4 months onwards, we see that infants are looking more in the direction of a pointing gesture or at the object that is being pointed at. And this helps in word learning, in general following speech, and in older children later on it has been shown that different co-speech gestures, when associated with speech, improves the following of the speech flow or even help in problem solving, like mathematical problems. But when you look at this literature, what pops out very strongly is that the focus for looking at gestures, the focus still remains on how gestures drive attention to the spoken components, to the speech components. However, the mechanisms which help detect gestures per se is rarely studied. And we think this is a key gap in our understanding of how multimodal language develops early on, for amongst various reasons, for the following main reasons. Because if there were any other modality that affords language, it is gestures. And this statement is not really hypothetical anymore. We have sign languages, which is based on the gesture modality, which shares features with spoken language. Even amongst speaking individuals, we have a more inter-individual comprehension across age, cultures, and language groups. If we look into ontogeny in development, language features first emerge in the gesture modality, and also going back in evolutionary time in phylogeny, we find that gestures in other primates also share these features that is common with the linguistic faculty. And for all these reasons, we think that it is imperative that we understand how infants are filtering out gestures from all the movements, all the other biological movements that are at their disposal early on. And this will enable us to understand how gestures are detected as an independent component of language, not just as a sidekick for speech. So that was the motivation which brought us to this question: do infants display any selective attention to gestures alone? And we went with the hypothesis that they will pay more visual attention to gesture forms than any other manual actions, similar to what they do with speech, that they discriminate speech sounds from any other sounds. So we used a preferential looking paradigm where infants come with their parents, of course, to the lab. They sit on the parent's lap, look at the videos presented on a screen in front of them, and then you see a little camera there, which is tracking the duration or where they're looking at on the screen. This is how our experiment goes. There is one trial, consists of a gesture and an action pair, and there are videos. Each video first appears separately on two sides of the screen, and then in the test display, we play them side by side simultaneously, and we repeat this test display 3 times. So each video is 4 seconds long, so the test display is 12 seconds long. And this is how the infants see it. And then the test display, which is repeated 3 times. And in our stimuli, we did not only have pointing gestures. We had 3 examples of pointing gestures, but we also took 3 examples of iconic gestures. Now, you all know what pointing is. Iconic is a little bit related to what we heard in the previous talk. So it's a gesture that represents an action or an attribute of an object. So this was a round block in our stimuli, and this was, I want the blocks closer to me. So these were examples of iconic gestures. And for each gesture, we had a matching action video, which matched not only in the form of the movement, it also matched in terms of velocity of the movement throughout the duration, and also the frequency with which the actress moved. We took 18-month-olds because we know by this age they have an understanding of pointing. They're pointing for a very long time by this time. But their level of understanding about iconic gestures, especially the novel iconic gestures, is a bit unclear in the literature. So we thought that we will piggyback right on this, because if at all gesture forms are fundamentally understood, then these iconic gestures that we used, assuming that they are new to the infants, most likely, they would still catch the infant's attention. So, for analyses, we first did the most traditional one that is done with preferential looking time paradigm. We looked at the average of the proportion of looking at the gesture videos and the action videos. So here what you see is just the gesture data, because it's at the 50% level of significance. There were only 2 videos. So anything significantly above 50% is preferential looking. And here we don't see infants are looking preferentially to the gesture videos. As a next step, we looked at the time course of the looking proportions. So we did not club all the looking proportions across the time, but we wanted to see at each time point how and where the infants were looking. Here you also see again the blue line is the time course of looks at the gesture videos, and with a cluster-based permutation analysis we found a significant cluster for looks at the gesture videos. This gave us some more motivation to dig into the data further bit more. We know that when the scene is very complex, it's a video scene, there's a lot going on, probably analyzing at the whole screen scale is not very useful. So we wanted to define specific regions, so regions of interest on these videos, to rerun the same analysis that we did before for the whole screen. So how we define the regions of interest is we took the gesture videos, and we defined the area where the gesture was executed, and we kept the same area and put it on the action video because it was also where the action was executed. That's how we designed our stimuli. So between a pair of gesture and action, the area remained always the same so that we could compare, but within a pair, sorry. And between gesture action pairs, the area differed because it depended on the nature of the gesture and action that we showed. And then we again looked at the average proportion of looking time in these regions of interest. The blue is the gesture and the red is the action. And here we see that there is a significant more proportion of looks to the gesture region of interest. And then we looked at the time courses for these regions of interest for these 2 conditions. Here again in the blue line you see the gesture looks at the gesture and the time course, and a very significant cluster emerges for the gesture condition. Now, since our stimuli consisted also of 2 different types of gestures, the pointing and the iconic, we wanted to look at the time course in the regions of interest for these 2 gesture types separately. On the left, right, it's your left. On the left, you have the time course for looks at pointing gestures, where you see a big cluster at the beginning of the videos. And on the right, you have the iconic gestures, where the cluster arises towards the end of the video. So we see that there is attention to both types of gestures, but the allocation of attention in terms of time scale of presentation of the stimuli is different. Now, the 2 most favorite words in a presentation, in conclusion. What we can say is, based on this data, at 18 months, infants are selectively detecting pointing and iconic gestures in a dynamic scene, And there are different looking patterns depending on the gesture type. Now we wonder why. Is it because of some low-level features that the movements are different across the videos that is driving their looking pattern? Or is it a more high-level feature that, okay, for understanding iconic gestures, because by nature I have to wait until it finishes, I have to look towards the end to understand its meaning. We don't know yet. We are doing some further analyses to test this, but it's already very interesting that the gesture types have two different looking patterns. But one thing that comes out very strongly is that when we are thinking about different signals, when language is concerned, we have to treat them differently also, no matter if they have equal or they're equally important or they're both very important. We need to understand the signals first. So for visual detection studies, it is definitely the temporal dynamics that matter mostly than average proportion of looking time, which works very well for auditory cues. So we think that as a future study, testing younger infants could be more informative on the whole developmental trajectory for how visual signals are detected, because at 18 months, infants are already very used to relying both on speech and gestures for understanding, and these videos might look a bit weird to them, so maybe testing even younger ones who don't rely so much on the spoken part of what they receive could be more, we could have stronger effects, but it's debatable. But then there is the possibility that there are other mechanisms. For example, maybe separate brain areas are dedicated for detecting gestures as communicative signals versus other biological movements. And this is something we are testing at the lab at the moment with FNIRS, but that's a story for another day. So at the end, I want to thank all the funding sources that made this study possible, my lovely, lovely collaborators, without whom this wouldn't be possible at all, the very efficient actresses who knew exactly what I wanted for my STEM, and a big shout out to all the families who volunteered participation. And thank you all for your attention, visual or auditory.